A virtual LAN, or VLAN, is implemented primarily to segment the network, but it can also be used to reduce data collisions, organize the network, and potentially boost performance and possibly increase security. A device such as a switch, as we're showing here, a VLAN switch, will often control that virtual local area network. A VLAN compartmentalizes the network and it can isolate traffic. VLANs can be set up in a physical manner. An example of this would be the port-based VLAN, where switch ports are grouped and configured to act as individual VLANs. To do this, you would need a managed switch, one that you can log into and configure for VLAN use. And that's what we have here. We have a switch that has connections to other switches. You could call this guy here a master switch, and he's got connections for all these other switches, which each go to different areas of the building, like the staff area, the library, classroom 3, classroom 2, classroom 1. So you can divide this up in a physical way, a port-based VLAN. There are also logical types of VLANs, such as protocol-based VLANs. A VLAN can be set up in such a way where each VLAN is on a different IP network. Like the example we're showing here, we have Classroom 1 on 192.168.1.0. Classroom 2 is on 192.168.2. Classroom 3 on .3. Library on .4. And staff on 192.168.100. So as you can see here, we have 5 VLANs, each connected to their own switches, and those are connected to the master switch. So this could be a great way to compartmentalize computers, printers, and other multifunction devices. In addition to doing port-based physical VLAN configuration here, we're also using IP networks. Or you could take it to the next level and incorporate IP subnetting. IP subnetting is when you divide the network into 2 or more subnetworks by changing the subnet mask that is used. For example, you might be using something like 255.255.0.0. You could change that to, say, 255.255.240.0. We're changing that third octet to 240, effectively taking our one IP network and dividing it into 16 subnetworks. Some administrators prefer IP subnetting over VLANs, and some use them together. For example, a group of physical port-based VLANs, like we have here, each of which is on a different IP subnetwork. Here we have them on separate IP networks. So it all depends on your environment. Let's show a switch that has VLAN capability. And again, you need to make sure that you're working with a managed switch. So this is a Cisco SG200. And if we go to VLAN management here and look at default VLAN settings, there's only one network right now. All the ports are part of one network. It's just one VLAN, known as number 1. But we could create additional VLANs from here and add on additional VLANs. We could call them 2 and 3 and 4, or give them a range. And then we could change the interface settings and specify which ports will go to which VLANs. And we could edit those ports and specify where they're actually going to, and do it by the port. So you don't really need to know how to create VLANs, but the idea is you can separate it by the port, the physical ports on the switch. And so this is known as a port-based VLAN. For the A+, you don't really need to know how to create these, but you should know what it is, how they function. And that SG200 switch, there's an emulator on Cisco's site for that if you want to work with that. Okay, so a little bit about virtual local area networks, also known as VLANs.